Java follows a paradigm called object-oriented programming, and in object-oriented programming, you'll be creating stuff called classes. And if you're wondering what class really is, then look no further to a more simpler programming language, such as C. And in C, you define things called structs. And what structs do is pretty much tell the program how to structure some memory. So for example, in this piece of memory, I'm going to have a count and I'm going to have a value and a list of numbers. And the way that you define it in C is through something called a struct. And if you look at Java or a Java class, then it's pretty much the exact same thing. However, there are more features on top of Java classes. So pretty much what you're doing when creating a class is that you're creating some kind of template for the program to use to read some memory. Now the question is, now that you have some template to read this memory with, how do you actually allocate this memory or be able to use a specific area in memory to have this object within? Now, if you're familiar with C, then you would actually manually allocate this memory, and then you would initialize every single value, and that could get a bit tedious. So what Java allows you to do is create something called a constructor. And what this constructor allows you to do is, first of all, it Java handles all the allocation rather than needing to manually allocate this memory, and it allows you to specify how exactly you want this object to be constructed. So for example, over here I have two variables, value and numbers, and I want to initialize these values when I create the class. And I'll get to how exactly you create this object in a sec. But pretty much I could say value, I want it to have a value as I defined in this constructor. And the numbers variable will be initialized when I call the constructor, and it'll take a number of uh, numbers that I want, and it creates some array of that size. Now, if I wanted to use this constructor, then I would need to go to the main function, and to use it, I would say new thing, and then I would pass in a bunch of values, such as 1 and then false. And now that I've created this object, I want to actually store it in some variable. So the way that I would do that is I would have some name of variable. Now I need, in Java, you actually need to define the type of this variable as well. So the type is the same as the class, which is also thing. So whenever you call new on some constructor, then in memory what happens is that it would create a new object and then it would initialize all the values within. But going back to C, if you were to allocate some memory, then you would also need to free it as well. But in Java, what goes on is that there's something called a garbage collector. So whenever I make a new object and I assign some variable to it, then the garbage collector knows that this object is being in use. But let's say that I make another, or I call another function, and I make another object, or I make another object, and I have this variable that's referencing this object. But whenever this function ends, and I don't return this variable, let's say, then there's not going to be any more references to this object. So what the garbage collector does is it periodically goes into memory and looks for all the objects which are not being referenced, and it deletes them. And it frees up this memory for other objects to be in. Now, this has lots of advantages. You don't need to mess around with memory, and there's no risk of having, well, there's lesser risk of having any loose memory or memory leaks. But the disadvantage is that you don't have control over when and how this memory is going to be destroyed or freed. And one example of this is, for example, in Minecraft. If you ever played multiplayer servers in that game, then periodically the game just freezes or just comes really slow on servers. And what's going on is that the garbage collector is trying to delete all the unused objects at the same time, which slows down the server overall. So it is a good solution if you don't want to be messing around with memory, but there are drawbacks. To use this instance of the object, what I could do is just write thing, and if I wanted to access some attribute in this class, then I could write dot, and I could see all the attributes as well as all the methods within this class. And let's say that I wanted to print out the value, so I could say uh, print out the value, which is going to be false. And if I ran this class, then I would get false. Or if I ran this program, then I would get false. And I could create multiple instances of this class. So let me just copy paste this. But the thing that I'll change is that I'll make the second object have a true value. So now when I print this, I'm going to get false for this instance of the class and true for this instance. And as you can see, false and true. Now, something that might be confusing to most beginners is that if I create another variable, let's say thing3, and I assign it to the same variable, then what would happen is that if I change the value inside thing3, then it would also change the value within the first thing, or the first object. And if I print out both of them, so thing.value as well as thing3.value, I'm going to get the same value. So I'm going to get false and false. Let me just remove that. So in the beginning, the first object which we created was false. That is what we assigned to it. And then we created a new variable, thing3, that is assigned to the same variable as thing. And then when we changed the attribute in thing3, it changed both of them. So if we take a look back at memory, then what happened was in this main method, we created one variable, and this variable pointed or referenced this object which we created. And then when we created a different variable, it also referenced the same object. So when we changed this one from false to true, it changed both variables' reference to the reference to the object is the same, and therefore both values changed. And when you created the second instance of the class, it actually created a new object, and inside the main function, this is thing2, and that referenced this. So if I changed this one, it wouldn't change this instance of the class. And this is important because if you make another if you made another function that took in this object as a parameter in this method, and you change it within this method, then it would also change all the other variables that are also referencing this object. So take that into consideration. Earlier, I was able to change this field or attribute or variable, whatever you want to call it, directly from outside the class. And usually you're going to be writing this class for other people to use. And in this case, I don't want people to be able to directly access this value field. So what I could do is I could go to my class and add something called an access modifier. And what access modifiers do is tells the program how you want this field to be displayed. So in this case, I don't want the value and numbers field to be shown whenever I use this class. So I add something before it saying that I want this to be private, or you can't see uh, this field. And you might have noticed across the program there have been other keywords such as public and also static. And I won't get into static in this video, but what public allows you to do is you could see this class from other projects and so on. So here I have this thing as private, so you can't see it anymore. But if I go here, there is the constructor itself is public. So if I go to here and I try running the new on this object, then it can run. But what I could do is say that this is private. So I can't run this constructor. And this is something you might want to do when you're using design patterns with more advanced usage of object-oriented programming. But now the question is, okay, what if you want to actually change these fields, but in a more organized way or in a more controlled way? So what you could do is use something called getters and setters. So let me just show you here. And the code is pretty big. Okay, so while you're programming and you want people to change these fields, but maybe not directly, maybe you want to have something in between, or make it easier for people to use this class, then you would create getters and setters. And pretty much what these are something called methods. So you could attach functions to some class, and these functions would allow you to use these variables within the class. So over here I have this numbers field or variable, and I could access it using this keyword. So as if you notice here, then I wrote thing.value, and this is outside the class. So I'm writing thing, and this is the actual variable. And in this object, I want to access the value field. But over here, I'm already inside the class, so I say this.numbers. So that's what this means. Now, sometimes I don't even need getters and setters. And what I commonly see is that some people just put getters and setters for everything, but you don't need getters and setters for everything. It's on a case by case basis, and the benefits or the real benefits that you would see is when you add custom methods. For example, if you want to add some number to this array of numbers. So if you're using it outside this class, then I would need to know exactly where in this array have I read to, and then I would need to make sure that the user doesn't mess it up unintentionally. So rather than worrying about what the user might do with your class, you could just add some method over here to add this number to this array for them. And I could add more specific logic. Let's say if this array is full, then I don't want people to be adding numbers to this. And this is just one example of many that you could think of. And also, I added this sum method. So it just goes through all the numbers within this array and it sums them up. So if I wanted to use this class or object, then what I would do is write thing.addNumber, and I could just add a bunch of numbers. So say 1, 5, 2, 7, 8, and I could just write thing.sum, and I got the sum of all the numbers. Now if I print out all the so if I print out the sum, then we should get the sum of all these numbers. And something interesting to see is that, okay, it gave me 1. And that's because I set the number of elements within this array to be 1. So if I make it, let's say 100, then I could add all the numbers. So that got all the sum of all the elements within. And there is a way to have dynamically resizable arrays where you could add theoretically infinite number of elements, but that's for another video. Although I only gave you a glimpse of object-oriented programming within this video, I'd like to mention the pros and cons of object-oriented programming. Now, of course, object-oriented programming is a really great paradigm for writing scalable and reusable code if you do it properly. And it is better than having no paradigm to follow or way of writing code to follow. But as a beginner, or I'm saying this to the beginners here, when you're using the paradigm of object-oriented programming, you're going to be focusing more on the structure of the objects and how these objects interact with each other rather than the actual behavior of your code. As an example, I wrote a very similar program without using any notion of object or classes. Objects themselves are not limited to only object-oriented programming, but are ubiquitous to pretty much every programming language. And pretty much what I did was I created something similar to a constructor, which is just a function that could potentially take in some arguments and return some object. Then I just created a bunch of functions that allowed you to add and do stuff with this object, and I use it within some main function. So this is an alternative way of writing code that does not involve classes.